And welcome everyone to Beyond the Forecast, your Friday version of Beyond the Forecast, which means a little something special by the end of the show. But today, meteorologist John Gross is going to talk to you about precipitation fog. What is it and when do we see it? So he's going to break down precipitation fog for you, and then he's also going to take you into dust devils. What are they, how they form, and how are they different than tornadoes? So meteorologist John Gross will take you into those two items, and then we'll also have Viewer Question Friday, which we're going to send it back over to meteorologist John Gross to talk about tornado formation. Now, viewer question came in and said, how do tornadoes form? So he's going to explain that for you at the end of the show. So meteorologist John Gross, heavy today. But before we get to those wonderful segments, let's get into some fun things today. At the top of the show, we always give you this day in weather history. So this day, May 30th, back in 1879, a major outbreak of severe weather occurred in Kansas and western Missouri. Now, in Kansas, tornadoes killed 18 people in Delphos and 30 people in Irving. 2 tornadoes struck the town of Irving within a few minutes of each other, virtually wiping the small Kansas town off the map. The second tornado, now, this one can be taken with a grain of salt, but they said reportedly the second tornado was 2 miles wide and exhibited multiple vortices. Wow, that's crazy, but that was on this day, May 30th, 1879. Wow. Trivia time. Yesterday, we wanted to know, when is the warmest month in Michigan? Is it August, July, June, or September? It's actually July. July is the month where we have the warmest average high temperature across northern Michigan. Makes sense. It's after the start of summer. August can be warm, but it's usually a week or two of warm weather. July is usually pretty warm the entire month. Today, we want to know, what temperature is it preferred to swim in Lake Michigan? Is it 60s, 70s, 50s, or 40s? And we're not talking air temperature here, we're talking the water temperature. So what temperature is it preferred to swim in Lake Michigan? 60s, 70s, 50s, or 40s? QR code right there. Hit it with your phone. It'll take you to where you can answer, and we will have the answer for you coming up next Monday on Beyond the Forecast. All right, viewer photo of the day, always brought to you by Great Rooms. Today's picture comes to us from Valerie Harmon, and Valerie sent in this absolutely stunning sunset from Onekama. Just a gorgeous, gorgeous picture. Thank you so much, Valerie, for sending in that picture. And also, huge thank you to Great Rooms for sponsoring Viewer Photo of the Day. All right, let's send it over to meteorologist John Gross to start off our segments. He is going to tell you all about precipitation fog. We'll have that coming up right after the break.
Hey there, everybody. Meteorologist John Gross. Welcome back to Beyond the Forecast. Today, we're going to be talking much more about fog. We've already talked about a few different types in previous episodes. We've talked about radiation fog. We've talked about steam fog. And today, we're going to focus on more of what we call precipitation fog. Now, if you've ever seen it get a little bit foggy after a rainy day, maybe the next morning, this is exactly what we were talking about. Now, just remember, fog, it's just a cloud at the surface, and that is just so happen to be where we live. So that can make it a little bit inconvenient if you're traveling on the roads, if you're flying out of the airport, visibility issues, things of that nature. So let's go ahead and talk about the setup that we have. Here's our rainy day. And as we are seeing that rain actively fall from the sky, we're talking about at least the layer of air above the surface becoming just a little bit warmer when you're talking about those rainy conditions. So as we have that setting up, now we have our raindrops falling throughout our warmer layer, and as it gets closer to the surface, those raindrops, well, they start to fall through at least the relatively cooler layer. And as those raindrops make it towards the cooler layer, that's when we start to see evaporation. So remember, when we're seeing the water evaporate, we're changing the matter of that water from the liquid to the gas. So now we have water vapor in a lot of it closer to the surface. So now, as we have that evaporation happening and we see our raindrops turning to water vapor, now we're starting to at least saturate the air closer to the surface, even after the rain is done and over with. And once we start to see that, then we go from evaporation to condensation. just the classic water cycle. So now we're changing that water vapor back into a liquid, and now we start to see cloud formation. But remember, now we're talking about clouds instead of in the upper levels of the atmosphere, even the mid levels of the atmosphere at the surface, and then we get fog to develop right where we live. And that can happen usually, again, after a rainy day, usually going into the overnight period very early on in the morning. As your temperatures continue to fall naturally at night, they get closer to the dew point. Remember, that's just the amount of moisture content we have in the atmosphere. And once we get those numbers very, very close, you couple that with a lighter wind, that can give us what we call precipitation fog. And we can see it time and time again because it rains all the time, especially not only here in northern Michigan, but across the United States. So big thing that we talk about with fog is usually visibility issues, and most of the time when you're talking about any impacts from fog, it's going to be found on the roadways, if not if you're doing some traveling at the airport. So we just like to go over some tips when you're traveling in the fog, as we're talking about now precipitation fog. And one of the main ones, use your low beam headlights or use your fog lamps. Do not use your high beams when you're talking about foggy conditions, or even when we're talking about instances in the wintertime. Lake effect snow visibility can be reduced very, very quickly, so it makes it look like you're driving right into a cloud. So again, low beam headlights, use your fog lamps, always give yourself more stopping distance, especially if you can't even see that car in front of you, depending on how thick or at least dense the fog is. So these kind of go hand in hand. If you're giving yourself more stopping distance, just slow down, drive for the conditions. If it's too thick, pull over, give it a little bit of time if you can. If not, use extreme caution and always get to where you're traveling safely when we're talking about any fog, including precipitation fog. I'm meteorologist John Gross reporting for Beyond the Forecast.
Thanks, John. Now, coming up next, meteorologist John Gross is going to explain to you dust devils, what they are, how they develop, and how they're different from tornadoes. We'll have that right after the break.
Hey there, everybody. Meteorologist John Gross. Welcome back to Beyond the Forecast. Today, we're going to be talking about another phenomena that you might have witnessed at least at one point in your life. We call them dust devils. Now, usually when we are talking about a dust devil occurring, it's not a big threat to life or property. It's a very small scale phenomena. It's something that we call a microscale phenomena compared to a synoptic scale or even a mesoscale. And when I say synoptic, I'm talking about those areas of high pressure, areas of low pressure. Those are usually a lot larger on a weather map. So for the dust devil, remember we're on that micro scale. So you're talking about a very small phenomena occurring. But when it does occur, it can be somewhat powerful if you're right nearby, or if you do happen to find yourself right in that circulation, because you are talking about winds technically rotating at the surface. Now, the winds themselves, they're not too strong, but still not a place that you want to be if you are talking about a dust devil. So here's a look at our setup, and when we're talking about dust devils occurring, we're talking about usually a nice sunny day. So that's going to be our setup here. We're talking about the sun heating the ground, which then that warmer air, remember, it's more buoyant, so it likes to freely rise. So as we continue to see that air rising, that air is coming together, and then it starts to move up throughout the atmosphere. So we have to have the air being replaced somewhere. So now we're having that convergence of air right near the surface. So that's what we talk about with this area of low pressure. So that's the initial setup. And once we start to get all the winds converging right near that area of low pressure, they're coming from different directions. So as we see that, that's when we can start to see some circulation starting to occur. And even still, that area of low pressure, as that circulation and the heat continues to build, that can help to not only sustain that area of circulation, but even increase the strength of that circulation. And once we have the circulation in play, that's when it starts to move from the surface up throughout the atmosphere. And as it does, it starts to collect dust, dirt, debris, whatever might be in the path of that little area of circulation. And that's how it becomes visual, at least to our eyes, to be able to see what we do call a dust devil. And they usually don't last long. They can last 30 seconds to a minute. In some instances, maybe a few minutes if you've got a stronger area of circulation, but like I was saying before, it's a very small scale phenomena that we do talk about. Now, comparing the two, at least from a tornado to a dust devil, there are a lot of differences. You can think of the dust devil, if you remember we were talking about water spouts before, they form at the surface and then they work their way up through the atmosphere. With the tornado, remember, with the environment, you need a severe storm and you need a rotating updraft, and it's usually also associated with a downdraft, and the origin of a tornado starts at the cloud and then it works its way down to the surface. Very different story when you're talking about the dust devil, and like I mentioned earlier, very similar to how a fair weather waterspout forms. The main difference between those two is, well, one's over land and one is over water, but the environment, it usually can just be a very nice sunny day. We're not talking about any chances for severe weather because it's a very small scale phenomenon. So this is based off of surface heating. Remember, we're talking about that warmer air rising freely throughout the atmosphere. It's more buoyant. It wants to freely rise. That's how you can get that area of low pressure starting in the circulation. And as it continues to move up throughout the atmosphere, it picks up dust, it picks up dirt, it picks up whatever it might be in the way. And that's what makes it visual to our eyes as a dust devil. I'm meteorologist John Gross reporting for Beyond the Forecast.
Thanks again, John. Now, coming up next, we're going to have Viewer Question Friday, and we'll have that for you to round out the show after this short break. And welcome back, everyone, to Beyond the Forecast. Now, usually at the end of the show, we tell you about our Beyond the Forecast live streaming podcast. But on Fridays, we do Viewer Question Fridays, where you ask us a question, and if we've had it on the show, we might rerun it, or if we haven't explained it, we explain it to you. We give you the science and weather of your question. Sometimes, for John, Haley, and myself, sometimes we just overthink it and think, oh, you should probably already know that, but sometimes you don't. So we either go back to the basics and explain things, or maybe we go back to where we've explained it, but you might have missed it. And that's the case for today. Meteorologist John Gross is going to take us back to one of our very first episodes and explain how a tornado is formed and how they work. Someone asked, how do tornadoes form? Well, guess what? We have you covered there. So meteorologist John Gross is going to break that down for you right here.
Today, we are going to touch on what exactly is a tornado. We'll go ahead and talk about how they develop within the atmosphere themselves. We'll touch on the enhanced Fujita scale, how we rank tornadoes based off of their wind speed as well as the destruction that they can cause. Also touching on radar and how us meteorologists use that tool to see if we are talking about an active tornado situation or not. So a tornado, we've heard of the term before, but what exactly does it mean? Well, you're talking about a very violent column of air rotating, and it has to be connected technically from the base of a cumulonimbus cloud, usually otherwise known as a supercell, all the way down to the surface. Once we have that in play, that's when we can constitute it as a tornado. So let's go ahead and talk about how they develop within the atmosphere itself. Let's go ahead and get into our 3D box. Now you're talking about winds moving in different directions to start. You have warmer air there at the surface indicated by those red dots, colder air in the mid-levels of the atmosphere indicated by those blue dots. And notice how they were moving in different directions. That's when you're talking about warmer air and colder air clashing together. That's the early indications that we can start to see for rotation to start to develop within the atmosphere. So warmer air at the surface, and then you're talking about colder air in the mid-levels of the atmosphere. Eventually, once we start to see that, that's when we start to see those early indications of rotation, otherwise known as what we call horizontal rotation, right there in the mid-levels of the atmosphere. So now we're starting to see that spin of the air, otherwise known as vorticity. So once we have that, now we need to get that horizontal rotation in the vertical. And that's what our supercell is going to help us with, as we can see very, very strong lift within these supercells, otherwise known as a very strong updraft within the supercells. And then we start to physically see that horizontal rotation being stretched within the vertical. And once we have that connection between the base of the cloud right there all the way to the surface, that's when you have your classic tornado. And that's the very violent, again, rotating column of air that unfortunately we see time and time again, not only here in Michigan, but in the United States, that can be very destructive. So that's how we see them develop within the atmosphere, but how do we categorize them? Well, we have a scale for that. We call that the Enhanced Fujita scale. We go all the way from EF0 to at the bottom of the scale, or at least the strongest tornado we can see, categorized as an EF5. Now, on average, at least here in the state of Michigan, you're talking about an average of around 15 tornadoes per year, and usually we are on the lighter end of that scale, meaning you're talking about EF0s, EF1s, or even EF2s. Now, we have seen stronger tornadoes in the state of Michigan before. They're rare, but it can happen. Otherwise, when you're going towards different parts of the country, usually areas throughout the Great Plains, when you think of Nebraska, Kansas, areas in the Great Plains, you're talking about otherwise what you may have known as Tornado Alley. If you're going into the south, you might have heard of what's called Dixie Alley. That's where you can see those air masses, the colder air and the warmer air, as well as a lot of moisture coming together, and that makes it a lot more susceptible for tornadic activity to develop. But you can still talk about these tornadoes all the way from an EF0, 65 to 85 miles per hour. On the high end, an EF5 that can be very, very destructive. That's when we can talk about the winds, 200 plus miles per hour. So that's how we categorize tornadoes. Let's go ahead and talk about how we see them on radar as far as us meteorologists and what we're looking for as far as indications go. So here's a look at it, tornadoes, or at least what we call a classic hook echo. So here's a look at those key regions that you're talking about within the supercell itself. So the leading edge of the supercell, usually otherwise known as a gust front, usually you can talk about very strong winds on the leading edge of the supercell. Heavy rainfall, indicated by radar, we can talk about that time and time again. Usually indicated the colors, the reds, the oranges, and the yellows, and even still where you see some of those very vibrant colors, the reds, pinks, even sometimes purples on the map, that's usually an indication we have a very strong hail core within the supercell itself. Here's the winds we're talking about. Warm surface winds usually coming in from the south, cold winds in the mid-levels of the atmosphere usually coming in from the north. That's when you see those air masses clashing together, and right where they meet, otherwise known as a debris ball. Sometimes we can see that with a very strong indication not only of rotation, but we can also potentially even see non-atmospheric things being lofted in the atmosphere, such as 2x4s, anything that might be in your yard. That gives us indications that we're seeing debris being lofted in the mid-levels of the atmosphere, and a debris ball also gives us that indication that we have a potential tornado on the ground. Now, it's not an actual confirmed tornado until we get clarification either from the National Weather Service or a trained weather spotter, but when we are looking just at radar itself, again, this is a very good indication that we have an active tornado on the ground. And last but not least, when you're talking about the tornado watches versus the tornado warnings, it's always a good idea to make sure that you have a plan in place, know where you need to go in case your area is ever issued, especially a tornado warning, and always having multiple ways to get weather alerts for your area in case you are ever issued, again, a tornado warning like we've shown you here. That can be very, very dangerous.
And thank you, John. That is how a tornado forms, and that's what you have to be on the lookout for. So that is Beyond the Forecast, your Friday edition, and another week is gone. And we'll be back next week with more Beyond the Forecast, more science, more weather, and hopefully a few more experiments. We're still in the process of getting a lot of stuff taken care of, but soon things will get back to normal for us here in the weather department. So for meteorologist John Gross, meteorologist Haley Fischetti, I am Chief Meteorologist Michael Stevens. Thank you for hanging out this week with us on Beyond the Forecast. We'll be right here at 4:30 on Monday with more Beyond the Forecast. Have a wonderful and safe weekend. Be good. Take care. We'll see you all on Monday. Bye, everybody.